All right. Welcome everybody to the Cyberbot Educator Workshop with Python and the Microbit. This is day one. We have a slideshow that you may find useful both during the presentation and afterwards. So I'm going to paste this link to the Google Slides into the chat. And then for any of you who are watching it on YouTube, later we have a shortened version with a bit.ly link, as well as if you have a mobile device and you want to check the slideshow, you can follow the QR code. Let's see here, chat. Paste. Okay, so there is a link to the slideshow. And this slideshow is going to be pretty useful. There's a lot of links embedded into it that you'll see me following. And if you end up going back to the YouTube presentation, you'll see me follow a link, and you can just go ahead and follow the same link from the presentation. The Cyberbot robot is this guy right here. And this was a joint project.
Before you get into this, we didn't get the link.
Oh, you know what? Somebody chatted me and it switched over to chatting back to just that person. Thanks for letting me know. That's great. Let's see. Paste. Did it come through?
Yep.
There we go. All right. Yeah, thanks again. And by the way, yeah, as far as presentation style goes, I'm very open to, in fact, I'd like to encourage everybody to, if you have a question, feel free to unmute yourself. If you're more comfortable just asking the question or making the comment in the chat, that is fine too. And Stephanie will be keeping an eye on that and let me know if there's something that she thinks needs to be brought to everybody's attention. In which case she'll unmute herself and and let me know. Okay, so yeah, the Cyberbot is a joint project between cyber.org down in Bossier City, Louisiana. They've been around for more than 10 years now. They're funded by the Department of Homeland Security, have a staff of roughly 25, and their mission is to create a cyber-ready workforce. There's a lot of emphasis, though, on national security and cybersecurity. Where robots like this one come in is in cyber literacy that kind of feeds into understanding certain cybersecurity things later. And cyber.org had been using other of our robots. And so they came to us and said, hey, we think this microbit would be a really great robot brain and have a lot of benefits. And so we joined them in developing it. We are Parallax. We're just outside of Sacramento, California, on your way to Lake Tahoe. We have about 20 employees and have been around since 1988 and came out with our first educational product in 1997. Our chief inventor is Chip Gracie, and his brother Ken Gracie is our CEO and started this education program, actually. My name is Andy Lindsay, and I studied electronics in college and then started rewriting and writing from scratch textbooks for Parallax after I graduated and got hired at Parallax. If you're wondering what is a Parallax, well, Parallax is a company that makes the brains and other things that go inside products and inventions. So the kind of brains that are one of Parallax's main products would be the kind that you would find in small appliances, like the programmable chip inside a microwave oven that when you press the 3 button, it beeps. And then when you press the 0 button, it beeps 2 more times. That is handled by a microcontroller, which is a small programmable chip that you write your program on the computer, load it into the microcontroller, and then the microcontroller does whatever you programmed it to do. And in the case of the microwave oven, that would be monitoring the keypad, updating the display, making a beep when you press the keypad. And that's a microcontroller sensing a change in a circuit. And we'll be doing that actually with our robot on, I believe, day 2. So yeah, if it's got buttons and a display, chances are it has a microcontroller that's similar to the ones Parallax manufactures. We manufacture some, resell others. And we also do a lot of the other circuits, the displays, the keypads, lots of sensors, radios, things like that, that go with a microcontroller. Microcontrollers, of course, are also used for proof of concepts and student projects and custom, like, for example, Deep Sea Subs or Us is not really a store that's around the corner. So engineers will buy microcontrollers to make a special thing that, in the case of this Harbor Branch sub, controls the direction of the lights through a joystick. I believe the basic stamp was in a joystick monitoring inside the cab, and then they also had ones checking sensors inside the engine compartments. So Chip Gracie, that again is this guy, our inventor, invented the basic stamp in the mid-late 90s, and this pretty much changed everything, because before the basic stamp, microcontrollers were kind of a with technical training only sort of device. Some very skilled hobbyists were who were deeply into electronics had also gotten the know-how to program microcontrollers, but it was typically a technician and or engineer level activity to connect circuits to a microcontroller and program it to do those kind of things like are in the microwave oven. So after Chip invented the basic stamp, it completely changed a hobby in prototyping electronics. And along the way, it was suggested to Parallax that since this thing was so easy to program, which is why it changed, it basically made the kind of electronics where you program something approachable, and previously it wasn't. And so because of the fact that it was so easy to use, we noticed that there was a lot of interest in schools, and that's how the Parallax education program got started. And one of the most popular applications over the years has been the two-wheeled robot that is, it's in many schools. And this is the original Bobot robot that was that we first made available. And it became very popular for lessons in electronics programming and electronics programming, computer science, and robotics. Each time a new microcontroller came out that became popular, we also incorporated that microcontroller into a similar robot so that teachers could have a choice of what they used as the programmable brain, because each one of these is going to have a language of its own. So programming language is one of the considerations. And so the Bobot robot here, the original, was programmed in BASIC. The Arduino robot is programmed in the Arduino language, which is C++ in a simplified wrapper. Then we have the Cyberbot, which is programmed currently in Python and through the microbit, and then the ActivityBot, which is programmed in standard C. So fast forward almost 30 years, and the latest makes microcontrollers easy and approachable for even more people is the microbit right here. And so I mentioned earlier that cyber.org collaborated with Parallax. We made this Cyberbot robot. And this is definitely a fun robot. I'm hoping you guys enjoy these next 3 days of workshop. So one of the cool things about the microbit is that it has a number of built-in features that with some of these other robots, you'd actually be buying a peripheral device, wiring it up, and adding some code to make everything work. Whereas with the Cyberbot robot, it has things like built-in push buttons, a built-in LED matrix display. But more importantly, inside it, it has a device called an accelerometer, which can sense tilt, and it has a radio. It also has light sensor, temperature sensor, pins that you can connect to circuits for your project. Here's the radio antenna. Let's see. Oh, and then the version 2 has a built-in speaker and a built-in microphone. So all these things put together kind of expanded what this robot can do without purchasing other peripherals. You don't need the radio or the accelerometer peripherals anymore because it's built right into the brain. And so let's see here. So that's the microbit, and it rides inside this little platform called the Cyberbot board, which is there to make the lessons consistent with all our other robots. And it's also been tested quite a bit. So we know that this is basically a good setup for students to use. So before we, I'm almost at the agenda, this is some kind of intro and overview stuff. Up front, I wanted to include some shopping and resource links. So these 2 slides have links to, first of all, the Cyberbot robot in all its different forms. And so you can click the link and then follow and when you follow it, it will take you to all the Cyberbot robot kit options, peripherals, etc. And then I have a similar one for just the microbit for teachers who are using the microbit this is the category microbit. And what ends up happening is if you follow this link, you will certainly see microbit kits, but you will also see everything that has a microbit in it. So that's why we still see the Cyberbot robot, but here is the microbit kit on its own. And here is a learning electronics with the microbit kit. So there's a lot of different things in here that either go with the microbit or are the microbit. The student lessons are at learn.parallax.com. So that's this link right here. And this is essentially the student workbook. And for the homework, you've already gone through some activities where you typed in some code examples and verified that they work. And those were right here in writing microbit programs. And so this is an example of a chapter in the microbit or in the Cyberbot book, which has prerequisites, programming, and lots of other stuff that I'll talk about later. Software, it starts with software setup, then some programming lessons, then something special that we have to do to our project to make it work with the Cyberbot robot. And then there's some additional computer science optional lessons that really don't come into play until you get to the cybersecurity part of the Cyberbot. And so then these are the main lessons with the Cyberbot robot. And it starts out with the basics of putting together your robot and some circuit lessons on the robot. And then we get to navigation, I'm sorry, is right here. Then we start adding sensors to the robot. And with each of these next chapters, the coding reinforces some kind of basic principle and sometimes adds new concepts. And then there's a different sensor and a different type of application. And then the optional lessons I mentioned earlier up here are incorporated into the cybersecurity lessons that use the microbit a lot, but also use the Cyberbot. Since they can all live on a radio network, it gives us a microcosm for, say, a cell phone or a corporate network with which to learn how to defend against cyber attacks. Okay, so today what we're going to do is introduction, which we're just about through with. After that, we'll talk about what we did with the homework, make sure everybody's okay with the material we covered, clear on the hows and whys of it. We'll try out a couple of example scripts and make sure that everybody's comfortable with using the online editor in the python.microbit.org online editor. We're going to add a module to our project, and I'll be explaining more about that. It's essentially the extra thing that makes it so that the microbit can talk with the Cyberbot board, yet your program and your students' programs remain very simple and easy to use. We'll calibrate the servo motors, and then your robot will be ready to build. We like to calibrate the servo motors before building the robot because the way that we recommend building the motors into the robot, it makes it kind of hard to get at those adjustments afterwards. And so then as homework, we'll have you build the robot. Then Wednesday, we'll do some navigation, see how some of the computer science concepts that we did earlier are reinforced and applied, and through both navigation and touch navigation. Then we'll have you build another sensor circuit, and then we'll pick up on that on Friday. After we're done with the last of the sensor circuits, we'll look at the educational resources that we make available for the Cyberbot, and also the ones that cyber.org makes available. I think the main thing as far as learning outcomes go, first bullet is, of course, very important to us at Parallax. We want everybody to have fun with this. And we want to make sure to get everybody through any potential sticking points so that everything works for all of you. That's why I'm available to meet up on Zoom outside of the meeting times, the session times, so that if there's something that isn't working for your computer, we can get you unstuck. And there are also a few things like adjusting those servos before putting them together that I think you'll find to be useful, because it'll kind of give you a direction in the class so that your students don't end up running to you en masse saying, hey, wait a minute, this isn't working. All right, so are there any questions before they, and then sorry, I forgot to mention, it's I really encourage everyone to just, hey, if you want to say something, unmute yourself. We like to hear questions from you. That helps us do a better job on both presenting and the written materials. So do feel free to unmute yourself, but your chats will also be seen and responded to. So is there any questions before I move on to a review of the homework?
If we were running this as a quarter class or semester class, I mean, do you see this as a curriculum for about 16 weeks, or is this how long, if the ideal progression?
Well, I would estimate that there's 40 to 60 class hours that can be done if you go all the way through the cybersecurity material in detail. And really push the students to learn and demonstrate understanding of each concept. You can go for a fairly good amount of hours, at least 40. And if there are shorter versions though, so this is used in many classes as an enhancement, or it's one of several robots in a robotics class. So those are different ways that they're approached, and they're also approached differently with different age groups. I've often seen that middle school teachers will take some relevant information and kind of condense it, from a chapter, and condense it into several handouts for the students to go through. Whereas a high school level class might approach the entire set of lessons as they are. How's that for an answer? Good enough?
Awesome. Good job.
Okay, thank you. All right, anything else before I move on? Great. Okay, so homework review. This is partially for anybody who's coming and seeing this at YouTube later, just so that they can know that we have some homework that everybody did before this workshop started. And the first part is essentially just making sure that your microbit can be programmed by the python.microbit.org editor, and that also that you can enter text and the microbit will hear it, and that it can also send text and you'll see it on the screen. And I know that some of you had some difficulty on that, and we'll talk about that in just a little bit. It may be a Chrome update. It may be something that districts are doing for, configurations of Chrome under the hood. I'm not quite sure yet, but I'll be, not many of you had trouble, but I don't want anybody to have problems. So we'll be making sure that the Microbit Education Foundation tech support gets information about what's going on if you're one of the teachers that is having some trouble with their computer recently. Now, this has a video that you can go through that's on YouTube, so you can just click the link and see step by step all of the things that we'll do just to make sure the microbit is connected and that you can load code in it. And then those steps are also documented after the video. And so that's one thing that we went through. The other was how to save and reopen a script. And I'd really like to emphasize this one. And so this is where we'll start doing a couple of things with our microbits. So saving, renaming, and loading a script are slightly different with this online web editor than it would be for, say, normal computer software. And it's definitely not like Microsoft Word, for example. So first of all, here is the python.microbit.org editor, and step one would be to give your script a name before you save it. And then step two is to hit load save. And a dialog comes up, and we always want to use, well, not always. I learned this from Alan during a previous course. He's here with us as well today, that there are some times when it's good for archival purposes to actually download the Python script. But most of the time, we like to download what's called a project hex. And part of that is because the Cyberbot module that makes it easy to program the Cyberbot is added to the project, and it travels with this hex file. If you only save the Python script, you'll have to re-add the hex file the next time you want to do something with it. Or I'm sorry, you'll have to re-add that module, that extra piece of code that nobody can see, but it's in your project. And because of that, you can type certain things to make the robot do certain things in your script. So after you click download project hex, then it'll download the project, and you'll be able to look at it in File Explorer in Windows, Finder in Mac, the Files app in Chromebooks. Any of those, you'll basically go to your downloads, and a hex file with the name you entered up here will be there. And so, and it also appears at the bottom of the browser. Now, you can also, you know what? I think I'd better just do this. We should all do this together. So let me get a browser into this window here, and we'll go to python.microbit.org/v/2. I'll paste this one into the chat. Okay, so there is your python.microbit.org editor. We're going to stick with the old version 2 for now, and probably between school years, we will update for the version 3 when it comes out, after it comes out of beta. So not now is what you want to say when it offers to try the new beta editor. So we're going to stick with python.microbit.org/v/2. And let's name our script hello. So that's in the script name. Just shade the name that's there. Name this hello. And then, so for those of you who had some difficulty connecting to Flash the program, at this point, you can actually hit the download button to get a copy of this script as a hex file, or just to make it universal so that it works for everybody, whether or not they're connected, you can hit load save and then download project hex. And then there is hello. And I've actually downloaded a script named hello a couple of times. So it says hello 2. So that's how to save. Now, then, if you were to take this default script and change it, like maybe we'll copy line 6 and say something else afterwards. Okay. It's nice to, oh boy, no, not it's. It is nice to meet you. Now, if you actually want to say it's nice to meet you in between quotes, instead of single quotes, you would want to use double quotes to enclose your string of text. And then a single quote is allowed within the string of text. So see how it's all still gray, and I should zoom in on this. Sorry about that. There, how's that look? So see how it's all gray, but if I were to instead use single quotes, what's happening here is that it is the only string, and then this is something that the microbit won't understand and will tell you that an error occurred while it was trying to execute the script. So you can use double quotes if you want to say, it's nice to meet you. So then, since we changed the program, the equivalent of save as would be to give it a new name, like hello greeting, or hello and greeting. There we go. Then you can hit load save and download project hex. And now in your downloads, you will have 2 files. It's going to be hard to see on the screen. Let me see if I can zoom in here. So see how we have hello and then hello and greeting. Did that zoom for everybody? Can somebody unmute and let me know if it did?
A little bit more would be good.
Okay. Let's see here.
And I actually see something on top of the code. There's a window showing on top.
I could barely hear that. One more time, please.
There is a window. There's the window on top of the code that we see here
Oh,
accessing things.
okay.
We see
So-
your downloads folder, but that is also obscuring the code itself.
Yes, yes. And
Okay.
right now, I just want to point out
Okay.
that when we downloaded it, thanks for explaining that. Yeah, I just wanted to point out that, you know, in your files application, be that Finder, Files Explorer, or Files, Mac, Windows, Chromebook, that you'll have these hex files here after you save. Now, watch what happens on the left here. We have Andy's MacBook Pro and a bunch of folders. And I'm going to plug in I'm going to take my microbit out of the box here and plug it in there. Okay, so we need the serial cable and set the microbits way down deep. So there is the microbit. Here's the serial cable. And so after connecting these to the computer, so I'll go ahead and connect the serial cable to the computer and then fish it over to where it'll be visible on the screen. And then I guess the microbit made kind of a racket the first time you guys connected it, I'm assuming. And that's the default program, and it sends data to the microbit or to the computer, and it also displays lots of things, and you might be able to hear the sound of it. There, it's going through increasing tones.
Andy, we have a question
Yes.
from Brian. Is this editor strictly online?
Yes, yeah, the editors that we recommend using are strictly online. There are some offline editors, and we do actually have support for the Mu editor on the learn.parallax.com website, but I have not been using it because I've noticed on my Mac at least that it tends to have some difficulties with keeping that Cyberbot module that we use to make the Cyberbot do stuff. It has some issues with keeping that in its project, and you'll see what I mean by that in a little while. So it's now prompting us to use the push buttons. And let's see here. Okay, so now I've plugged this in and I'm going back to Finder, and really important thing here is that now right below Andy's MacBook Pro, we can see a microbit thing that looks like a flash drive. And the most the most elementary way to load one of these scripts, like hello world, would be to go back to Finder, go to your downloads, and then select one of these hex files and drag and drop it onto your microbit. Now, when you let go, it'll show the hello and greeting briefly as it loads the script into the microbit. And since this is the first time I've loaded a script, it may also be updating the microbit runtime. It usually takes a little longer. Okay, so there we go. And then the Finder disappears. And what that means is that it's running the program. There's a little reset button on the back right here by the USB cable, and I can press and release that to restart. And then we see the hello world. It's nice to meet you. And then after that, we'll see a beating heart, or no, just a heart shape. So that's the first way to load a script that you wrote, is just to drag and drop it onto the microbit's flash drive instance. And for any of you who, I believe there are a couple of you who are unable to do what I'm about to show you next, which is why I showed you that first. So for those of you who had some trouble with the tests where we were typing in a message into a terminal, let me know, please, if what I just showed you works, if you're able to make, and I'd like everybody to try it just so you know that that's a way to get a script into your microbit. So could we all try that? You can just use the default script or, make a modification.
We have a report from Josh that the drag and drop didn't work on his.
Okay.
Is there
Now,
alternative?
Josh, yes, there is an alternative. Josh, were you able to get it to pass the other tests? Were you able to get it to pass the tests where you hit connect, select your microbit? Actually, I'm going to cancel out of that.
Yes, it works. It works when I just do a standard download when I'm on the python.microbit. But when I actually dragged and dropped it from my downloads folder, it took it, and the .hex file, it closed out the microbit file folder, and it doesn't show the hex file in there anymore. But I hit reset and it still wouldn't show up. But if I get back onto the microbit and download or flash it, it does fine.
Okay, so that's the second approach, is to hit this connect button. And this was all part of the homework, and then in that document that I looked at, or the thing I just showed you with the drag and drop was not in there. But now we're back to the the test that we ran and the homework. So so when you hit the connect button right here, you'll get a dialog. And the dialog asks you, which microbit do you want to connect to? Well, we only have one connected right now, but there are cases where you can have, 2 or 3 connected to the same computer, and you'd be choosing between microbits in that case. So you have to choose a microbit and then hit connect. And then you get the happy connected face as the button, and then the option to disconnect. And this download goes away. This used to be download. Now it's flash. When you're connected, you're going to flash your script directly into the microbit. And so that's why we use load save, because we can't hit download anymore to save it as a hex, but load save allows us to download Project Hex. And then the last item, by the way, is if you want to open a file, you also hit load save and then just hit browse for a file. So right now I have hello greeting, and if I want to go back to the original hello world, hello greeting is going to go away. There's hello world. So again, if you want to open something that you've saved, hit load save or browse for file, and then select your hex file. And when you open it, and I think so here we are at hello, second version of it for me. And if we want to open hello and greeting, we can select that in our, in the dialog that comes up. And then hello greeting comes back up. So then if the other way to load that, now that we're connected, the quick and easy way to load a modified script into your microbit is going to be, I'll modify it here. Oops.
I just wanted to mention, I think when some people were saying they don't see the file, that when they drag it over, you don't actually see the hex file once you drag it over. So I think that's what a few people might have been.
Oh, thank you for chiming in about that. Yes. So when you drag and drop the file using Finder. So first of all, I've got to get Finder back here.
I just know for people who are used to seeing a file appear when you drag it,
Exactly.
yeah.
Yes, exactly. So sorry, it's taking me a second to get Finder up here.
We do have a report from Justin that his doesn't load at all. It has a frowny face.
Oh, so now it was connecting, but it's not connecting now?
It says mine doesn't load. It has a frowny face.
I've
Oh.
seen that, Andy, and one of the solutions that I've found is go to just your basic MicroPython, your pythonmicrobit.org. Just take the default, any program, just that default, and flash that on there. The new microbit seems to know when it's unhappy if code did not fully flash, and you will get a frowny face that looks ominous. But I found that even in the middle of updating firmware, if something happened, I can go back and just flash a really simple program. That's been helpful.
I have found that too. The catch is that with Justin, he could not get it to flash either. And so that in mind, it also does not surprise me that he could not get it to connect. So Justin, I would suggest next unplugging your microbit from your USB port and from the cable, plug it back into the cable, make sure it's firmly connected, and also try a different USB port if you have more than one on your computer. Otherwise, just count to 10 and plug it back in. See, and we'll see if you can get either of the script loading methods to work then.
So Andy, I have another question too. I was, and I had emailed you about it. If I create my own script from scratch, like as was, from the homework instructions, it wouldn't flash. But if I go to the default code and I edit the default code, it works. So just a little bit of tidbit of information. And I'm very, I'm watching my syntax, I'm watching, logic and all that stuff. And I'm not doing anything different. I just can't get an original piece to flash.
Okay. I'm trying to think of what would,
I have a question on that one. Susan, what operating system or type of computer are you using?
I've got a Windows and I got a Dell.
Okay.
Okay, so what about the flash drive method that we just used? If you were to be not connected, so basically disconnect and then just hit download. And then there's a little caret you can click to do show and then try dragging and dropping it from your downloads into the microbit. And this is where, I'm sorry, I forget who mentioned it, but they said that, hey, the file doesn't show up in my microbit. And that's correct. We don't want the file to show. I mean, it may show up briefly, like for example, mine is showing briefly, but as soon as Finder closes and the script starts running, if you go back to microbit, you won't see it in the file contents. And it's because the microbit moved it from the file contents into another area that we can't see. And that's where that's an area that it uses to actually fetch and execute the statements in the script. So did that work for you? If
I will give it a try and see what happens.
okay, let me know. Or let us know.
Justin mentioned that there was just a little typo with a spacing issue, and that's what
Oh.
caused his frowny face. So sometimes it's something that's not obvious.
Oh, okay. Thank you, Stephanie, and thank you, Justin. All right, so let's go ahead and add a syntax error. Display.scroll on line 5. And so the microbit is not going to recognize that. And yeah, sorry about that. I didn't make the connection earlier. All right, so if we try to run this now, there's the frowny face. Oh, no, you can't see the frowny face. Okay, I'll restart the code. So there's the frowny face.
Yep.
And what that's telling you is that there's a syntax error, and anytime there's an error in the script, the microbit just stops. It cannot continue. And so for those of you who are able to use the connect flash open serial, which we did during the homework, notice that now, instead of seeing, a message that we use print statements to display, we have information. It's saying, hey, in line 5, there's an error. And the nice thing about this is also what it says on the microbit, but that can be kind of hard to read. So one of the reasons I really like using this serial terminal, the open serial button, is because it immediately shows you the entire text of what the error was. And so when your students are writing code, if you show them this, they'll be able to get to the root of whatever problem they have more quickly. And that is the frowny face mystery solved. Thank you, everyone. So that's the 2 ways to load a program into the microbit. Again, the one way was using your file browser. And then the other way is to click connect, select flash. And if it's just displaying on the LED display, it'll start displaying. If it has prints instead of display.scroll, if it has print statements, like if we say print hello world and flash that, and then open the terminal, we will see hello world. Not exactly sure why it appeared twice. Now, for those of you who don't see it, Control D to reset can cause it to happen, can cause it to repeat. And sometimes close serial and then open serial will cause it to appear if it doesn't appear the first time. So if it doesn't appear the first time, close serial, open serial, and or Control D to reset. That'll restart it. Of course, you can also just go ahead and press and release the reset button that is by the USB cable. And every time I press it in the terminal down here, you can see a new hello world because I'm restarting the program using the microbits hardware. All right, and Yeah, we have enough time to do this. Okay, so the next thing that I wanted to, or the next homework item we did was some tutorials. And here's an example of scrolling text, although I'm actually going to go to solve math problems. So this is, well, no, I'll just start at the beginning. Sorry. It's going to get kind of out of order here. So the first homework we did was scrolling text. And the recommendation I made, especially for any of you who are new to Python, is to tile your windows. Here's the edge of the window. To basically tile your windows side by side, or make a printout if you're more comfortable with a printout of the tutorials. But what you want to do is have your, and this is also best for the students too, is you want to have the material you're learning somewhere, so that you can go through and read the explanation of how we're going to use the display.scroll method. And then there's an example program, and then you keep reading, and it has the checklist action item instruction for a test. And then it goes through and explains how it works. Now, the most important thing is to not do this if you want to learn a language. Oops. Okay, that is going to make it easy to kind of get lost pretty quickly, because we won't have, as learners, we won't have kind of a solid experience of some previous steps. So instead of doing what I just showed you, what I want you to do if you're learning Python on your own is to actually go through and type it in, hashtag hello.py from microbit import star display dot scroll hello. And in doing that, it just gives you more time to look at the code, and it also somehow sinks into one's understanding in a easier to remember and build on kind of way, so that when we get to the how it works part, it's more loaded into your mind. And so when you see that it says the first line hello.py is called a comment, and it explains that the microbit won't execute that line. It's just for you to be able to read. And that the second line, it explains from microbit import star. And then it goes on to explain how the third line displays the message that is contained in these parentheses on, since it's display.scroll, it displays it on the 5x5 LED matrix. And so by having typed it in like this, it makes understanding what's going on a lot simpler. It also can help with curiosity. So students can say, okay, well, what's going to happen if I make this message longer? What's going to happen if I, add another display.scroll, things like that. And for students who aren't experimenting that way, we do have things for the students to try. So here's another program or another script that they can try. And then there's also a challenge that is not solved for them. It's only solved in the teacher files. And so by going through here deliberately, step by step, and hand entering the code and reading, hand entering the code, testing it, experimenting with it, that's going to establish a foundation for understanding the microbit better. And so if you're new to Python, I highly recommend this approach before you start teaching it to your students. And then I highly recommending it to them as well. And you may even find yourself creating screen captures of certain scripts so that the students have to type it in, or possibly making some handouts based on modified scripts, if you find the need to do more than just encourage the group, then those are things you could do. All right, so let's
Question
take
or-
5. Oh,
And
what-
before you go, is there a code bank to use with the Cyberbot?
is there a code bank to use? Stephanie, is there? I don't remember.
I don't think we made a code bank for this one.
Yeah, we
but I
probably should.
I think that you had done that with the cybersecurity scripts. Put
Okay.
them all. I don't think we
Educators.
have it all in one place. There's places where you can download code in the various tutorials where you have a download button.
Yeah, because as an example, learn.parallax.com, if we go to the Arduino robot, I know that,
But that has one zip for the entire tutorial.
yeah, exactly. So there's essentially a download, should be right here.
Yes. That's the book. There we go.
Yeah, right here.
Yeah.
So yeah, we should put one together. Thanks for asking. Sorry, we don't have it yet, but we'll add it to the list. I'm going in and doing some work on this document this and next week also. So I'll keep that one as part of the list. Okay. Oh, it's just going to take a couple more minutes. I wanted to check with all of you. So we tried hello. So that's one of 5 essential scripting tasks. Those being communicate. So we're writing a script to make the microbit communicate. We also have writing scripts, or writing statements to make the microbit remember values. And so we can say A equals 42. Then later, when we use A in display.scroll A, A is 42, so display.scroll A will show 42. C is the character M, so it'll display M. And then D is a decimal number, and it will display 42.06. So this is the remember, and this is the recall, or store and fetch. And then let's see here. Then there's there's communicate, remember, calculate, decide, count, and repeat was appended on there. And then, because really count is a calculate, it's doing repetitive tasks that I would say is the essential. And then we added constants and comments. So these are the things we did. And so make decisions was a script where we set 2 values and then checked what it would display based on the relationship between those 2 values. So we have if A is greater than B, then display.scroll A is greater than B. Otherwise, display A is not greater than B. And what do you think would happen if I did not indent right there? Anybody want to hazard a guess? Okay, well, we can flash it.
You get a sad face or?
Yeah, we get the frowny face. And then it tells us that there's a syntax error on line 8. That's exactly right. We get the frowny face. And the reason is because an if condition has to have one or more statements below and indented from it that it does if that condition is true. And likewise, else needs to have one or more statements below and indented if it's not true. So I could have more than one statement here, as long as it's below and indented. And so this will still run. There's count and repeat. And so you guys got to try, I believe, counting from 1 to 10. Is that right? So did you notice that the count was inclusive of the first digit, but it never made it to 11? So that's a useful feature when going through a string of characters and looking at them one at a time, because this is the 0th character, first, second, third, fourth, fifth, sixth, etc. And since we start counting at 0, the not going to the final number means that it doesn't try to check something out here. And so that's why it's inclusive of the first value and exclusive of the last value. And then constants. So I don't know really how, oopsie, here are constants and comments. So these are notes to self, and there's different ways to do it. So for example, if you put 3 quotes like this, you can add more than 1 line of info, and it will still be ignored by the Python runtime inside the MicroPython runtime inside the microbit. And with that, then you can also essentially declare variables like start val, stop val, and step val. And by giving these values names, then instead of for counter in range 1, 11, 1, it's going to be start val, which is 1, stop val, which is 11, and so on. And so that's important too, especially a number of industrial and commercial folks who want their engineers to document their code so that other engineers can pick up where they left off.
I have a question about, is this triple quotation marks universal for Python or just within the microbit?
It should be universal for Python. I don't program a lot in Python, and I'm getting a yes nod from Alan. Thank you. Alan teaches Python. Yeah. And there's more about that in the cybersecurity section. We talk about how this is actually turned into a giant string of characters. And with that, I would like everybody to take 5. Go ahead and stretch your legs, grab a drink of water or whatever, and we'll see you back at 4:13. And I'll hang around in case anybody wants to ask additional questions.
I'll keep the recording on though.
Okay, yes, thank you. I forgot to adjust for everybody's time zone on that 4:13.
You could really mess them up and do GMT.
-8 for me and you.
All right, I'll go get water.
Andy, how are you, sir?
I'm doing well, thanks. How about you?
I'm awesome, man. My name's Gabriel Cirillo. Can I make a couple comments real quick? I took a couple notes.
Oh, yes, please.
First off, thanks. I've had these bots. I got a dozen of them that I got from cyber.org grant a couple years ago, sitting in my closet. And last year I gave a small group of students, and if they loved it, they had a great time with it. The sign up for this actually was back in like May. And I signed up and I said, next year I'm going to really want it. So I've got a couple higher level learners that are really stoked to be doing this with me. So they're kind of on the backside. They're going to follow what I do. And I'm really excited for that. So thank you for that. Yo, Tommy Gober from over at cyber.org says hello. He says you guys always catch up when you guys are at conferences.
Oh, yes, we do. Yeah, we saw him at the.
I was with. Go ahead.
Were you at Washington, D.C. this year?
I was not, but I did a meeting with those guys last Thursday. I do a lot of that online cyber.org training they do.
Oh, yes, yes.
That was the first time I had met him, and I told him I was doing this next week. This was last week. And he said, I definitely have to tell you hello from him. So Tommy Gober says hello.
Okay. Are you going back to Tommy's training? Because you got to say hi to him from me now.
I will. So I'm actually going to see him Thursday night. So I'm stoked about that. Definitely.
Yeah. So Tommy is the guy who bought a microbit. Tommy is the guy at cyber.org who bought himself a microbit, and one for Chuck Gardner too. And they were playing with it on a flight somewhere, and just, saw the educational potential of it and brought it to us. And initially, I think, I don't think Parallax jumped on it initially, but then they really began to see that it was going to be a great thing for a two-wheeled robot, especially. And so they embraced the project eventually, but it took, I think, more than one conversation to get that one rolling.
I believe that. So just a question. So I've always aimed these bots at like higher level students. Do you think it's a good segue for maybe lower level students? And I use that term very loosely there when I use that, but it's like the kids that get all the work done. They want to be coders their whole lives. They love it. They pick right up on it.
Mm-hmm.
Do you feel like I should be implementing it with maybe some of the students that don't want to do any of that, and maybe give them a different angle?
Oh, heck yes. And as a matter of fact, that is the next thing I'm going to talk about. So this slide is all the fun stuff you can do with a microbit.
Cool.
And the next two slides, actually. So there's so I'll be mentioning this before we and I think we'll be skipping some kind of general material here. I want to make sure we get all our hands-on stuff out of the way.
Cool. So thanks again. I just wanted to make those few comments, and I do appreciate you.
Okay. Yeah. And thank you.
Man.
Yeah. Thanks for keeping notes, and yeah, stay tuned, because after the break, we'll talk about essentially things that you might get younger students started on to get them excited about this, and then possibly take more interest in challenging themselves with the robot.
Perfect.
Let's see.
Hey, Andy.
Yes.
So I had a question. I run the microbit and I flash everything, and I open and close, but there's nothing is this showing on the display. Am I supposed to see anything in the display or not?
It depends on which script you're using. So let me paste in a script to you. Let's make sure that this one works. Okay, do you see how it's counting?
Right.
Okay, so
But
I'll
on
go
mine, I
ahead
don't
and.
see anything.
Oh, okay, and I'm actually going to pick a shorter script just because I don't want to run out of characters when I paste it in. So I would like you to paste this script in.
Andy, something I've noticed on that is when typing, there's a tendency to play with display.show versus display.scroll. And if you do a display.show and you're doing a counter, it flips through at, in a jiffy, meaning in just
Does it though?
microseconds. With scroll, it does not.
Well, it takes more time, but there's a default time that show should display.
Show just flies through.
Okay, let's try that.
Yeah.
Okay, slash.
And the only one that
Ah.
appeared was 1-0. And the reason that 1-0 appeared is since it's still show, if you had the number 101, it would do 1-0-1. They're not scrolling, but
Uh-huh.
show just flipped through. There was no delay. The solution is asleep. Yeah, 200 milliseconds.
There's also actually an argument in display.show. So
Yeah,
so
you
these
could
are
do-
two
and
things I want to talk about.
And it's delay within the parameter, which is weird.
Something like that.
Yeah. And then get rid of the other one.
Yeah, and that is actually in the tutorial. Oh no, that didn't work. I did it wrong. I'll have to look that one up. I don't remember. Although this should do it. There we go. Is that rendering on your end?
Like yours?
Yeah. Well, no. Did the video render okay in Zoom? Or should I slow it down a little more?
I don't know. It was fun.
Okay.
Like watching. Oh, okay. You're using Visualizer.
Yes.
Ah.
So so it's rendering okay?
Yeah.
All right. Let's zoom in on that a little bit.
Ah,
Mina Bichet, did any of that work?
No, I think I have to reset it. I tried that, but for some reason it's still like when it resets, it keeps flashing.
Okay, so are you able to connect and disconnect?
Yes.
Okay. And then did I paste this in so that you could paste it right over your existing, and we want to paste it over the entire thing, not, don't leave anything behind from like a previous script.
Okay.
Oops. Chat.
are we done with our break?
Yes. But we're on a tech support mission right now.
And weirdly enough, that delay as a parameter is not working there. And I'm having the same issues. I'll work on that.
Well, it brings up okay, what if we want to add a delay into display.show? Well, we can hit help, select documentation. This is mentioned in the tutorials too. I'm just kind of going through it kind of quickly here. And then we can type display.show into the search. And I see a display.show. Oh, I see. So we've got a lot of options here. I think MicroPython API display looks sort of promising.
It worked.
Oh, okay. So there may have been a syntax error in your script.
Yeah.
Excellent. Thank you for the report. There's also images. I wonder if these do display.show. Yeah, display.show. And then, okay, I'll have to look that up because I'm not remembering. I thought it was, I thought the delay, yeah, look at that.
It is. But
Maybe we need the loop equals true. Okay, so what is loop equals?
loops and animation, like when you're saying show all clocks, in that case, all clocks represents all of the different hands and their varying positions. So
Okay.
that one is.
So
kind of
it's
strange.
crawling through the different clock positions. So we shouldn't need that.
Correct.
Okay, that's interesting. I'll have to get back to you on that one. Thanks for pointing it out. I don't know the answer because I expected it to work and it didn't. Try one more time.
Yeah, all the parameters in this range function don't
Wow. Yeah,
work.
so that's not working as documented currently. And I don't
Yeah.
know the answer, but I'll definitely check and get back to you. Try to get back to you on Wednesday.
And the workaround is obviously just a sleep function.
Yep.
or a
So
sleep bed.
if we instead use sleep like so and flash it, it counts nice and slow because it updates the display and then waits for 1,000 milliseconds, which is 1 second before doing it again. So here is the modified version for all of you to try. If you're using, and this was just the subject of display.scroll, which goes slowly, versus display.show, which seems to currently be going very fast. And I thought it was actually supposed to have a default amount of time. I'm not remembering it. It seems like something changed because it didn't used to behave this way. This may be just because we now have version 2.21 microbits. Possibly if I update the firmware, that could, yeah, I'll let you know on Wednesday. All right, so another question that came up during the break was, hey, what if I have students that just want to have fun, but we want to try to motivate them to get excited about this kind of stuff? And is there something before the robot? And the answer is yes, there's a wealth of lessons before the robot. So things for students to try, just to have a great time with it, are on Make It Code It. My favorite example is the step counter, because it uses the accelerometer. And so when you follow the link, and I'll give you that link in a minute. So when you follow the link, there's a video about it, and then you can choose, it starts by showing you the block code, which for some of you is going to be an attractive option for just getting your students started, younger students, with the basics of programming. But there's also a Python choice. So it defaults to block code, but don't be discouraged by that because there is a Python example. And then you can actually just hit the open in Python link to get the code into your Python editor. I didn't mean to close that. Okay, so I'd like everybody to try that out. Just copy the link in, open it in your Python editor, and then copy the code to, and you don't need to hand copy right now because we need to be mindful about the amount of time we take. So we'll be, despite the fact that I recommend learning Python by reading carefully and typing in the statements for the sake of getting through more material during this workshop, we'll be doing a lot of copying and pasting. And I didn't hit enter in the chat, sorry. There. Oh, I pasted it in twice, sorry. Paste. Now, once you've loaded this code, nothing will happen initially, but each time you shake the microbit, it will increment the number. So the idea is that you can mount this on your shoe to count how many steps you've taken. And that's just one of the hundreds of fun, exciting examples that are on the Microbit Foundation's website, microbit.org. And I put a bunch of other ones: beating hearts, emotions, sending a smile. If you have more than one microbit, you can use the radio to send emoji. Students will like that. And then that's basically the tip of the iceberg. What I included here on this slide, especially this one, we did a survey of what microbit.org has available in terms of lessons for middle school and in some cases younger. And we went through a very detailed look at how to use all their microbit resources, just using the microbit on its own before graduating to a robot. Now, I have a bunch of slides about why Python is great and MicroPython, and what I'll do is I'll loop back to those if time permits. I want to first make sure that we all get started with calibrating our servo motors. So I'm going to jump a little ways ahead here to talk about how your Cyberbot board works. So here you have the microbit. You're writing a program. This is really a great little graphic, by the way, Stephanie. So we're writing a program. It goes into the microbit. When it's a program for the Cyberbot, the microbit actually talks to a microcontroller that's built in to this Cyberbot board. And then depending on what the microbit tells the Cyberbot board, it will control the servos, update electrical connections next to the prototyping board here where we build circuits, and a number of other things. But it all happens because of a conversation between the microbit and the propeller microcontroller, which you'll see underneath on the other side of the breadboard on the bottom of the Cyberbot board. Now, instead of writing the low-level code, making everybody write the low-level code to have that I2C, I2C conversation with the other microcontroller, what we want to do is add a pre-written module that that will take simple statements that you write and then do all the rest of the hard work behind the scenes or under the hood. So I want everybody to go to this page that I'm going to paste in. And so we have a couple of animated GIFs that show how to do this along with some checklist instructions. And I'll go ahead and walk you through it. The main thing to do is to go to the Cyberbot Library Archive. Oops. Sorry, for some reason, I'm not copying the link. Copy link address. Paste. Okay, so that's a link to the Cyberbot Library Archive. And when we go there, the latest version is 0-9-2, and just download it. And it's going to be a zip file. And after you download it, you'll want to open it in your file browser. And then usually just double clicking will do the trick. And when you do that, it will create a folder for you. And there may be some, it might ask you where it wants you to put it and some other things like that. But after you, so another way to do it is to open it with Finder. Oh, actually, it won't let me do that. If you have a Chromebook, you may need to double click this and then right click and copy a folder that you see inside the zip, then back out to downloads and then paste that folder into downloads. That's what my Mac just did automatically twice, since I double clicked it twice. Anyway, the end result is you need to unzip your zip file that you downloaded. And then in there, you're going to see the cyberbot.py module. Now, we're not going to do anything with it from here. Okay, so I'll give you guys a couple minutes or a little bit to catch up to me. And then I want to make sure everybody has their Cyberbot zip downloaded. And then that you've all got it unzipped so you can see a folder that says cyberbot-MicroPython. And if you would give me some thumbs up when you, thank you, Alan. Excellent. David, yes. Jules, yes. WB, awesome. Amy, thank you. And I need to check the other page too. Thank you, Randy. And I know I missed somebody. Good, Justin, excellent. So what I'm going to do now, I think that's most of you. If
we do have a no.
Oh, we do have a no. Okay.
Marcel.
Oh.
And then we have a couple of people who have to depart right now, but we'll catch up in the video.
Okay, so folks, for those of you who have to depart, remember to come back and check out the YouTube recording to get the rest of your stuff. We'll talk about centering servos and before we put the robot together. Marcel, do you need some time or some advice? You're muted.
This is where I got stuck and I got frustrated.
Okay.
Once I get it downloaded, then it's just stuck. I try to open it. I didn't even see the pies in there when I opened it last time when I extracted it.
Okay, what happens when you right click the zip file?
When I right click it, it says that I can open with new window, share with Skype, extract all, pin to start.
Okay, let's try extract all.
Okay. Extract all brings me to a compressed file that I got to select the designation that I want to go to.
Yeah, so go ahead and hopefully it'll just allow you to put it in your downloads folder.
Okay, I selected downloads and then hit extract. And sorry, jumping screens. Okay, I don't see it anymore. Where'd it go? Yeah, and I lost it.
Go ahead and start over. Just right click the zip, select extract all.
Okay. Then I'll try to put it in download again. Okay. And extract. It says replace the file. Yeah.
Okay, so you already successfully extracted it. Go ahead and just select yes.
Okay. So
I'm guessing that when he unzips it, the folder generates, but if he's on like a Windows, it jumps to the top of the file list. So not where the zip file was. So if he scrolls up, he might see that folder.
Yeah, so another thing you may want to sort by date. If it's sorting by name, there'll be a name and a date heading. And if you click the date heading, it'll show a little up or down triangle. And if the triangle points down, that means the most recent stuff is at the top. So it's a column heading of your file explorer.
I think I found, okay, I found it. And then we go into circuits. Is that where we go, or examples?
Well, bear with me. So we'll take everybody through the next step. All right. So where are we? Okay. So now that you've got that in your downloads, the next thing is to hit load save. And then select, need to zoom out. Load save. And then we want to do show files. And then add file. Then it should put you in downloads, and you want to find your Cyberbot MicroPython folder and then select cyberbot.py and hit open. I'm going to do this one more time.
I don't have the CyberPy in here at all.
Okay, so let's watch as I do it. And let's see, first of all, I need to get rid of the cyberbot.py file. So I just hit the trash can to delete it. Okay, so load save, show files, add file. Now what you want to do is go to downloads. And in downloads, you want to find the Cyberbot MicroPython folder. It should have been extracted there.
There's also a suggestion to try saving it to the desktop where it's easy to see.
Okay, yeah, there we go. So another thing you can do is extract it to the desktop, Marcel. So, so again, find the Cyberbot-MicroPython folder. And that can vary with how you have your downloads sorted. And you might have to scroll way down to the bottom where you have folders. And then the other thing to do would be, as was pointed out, instead,
On your files, when it shows the pi at the end of the files. None of my files say pi at the end.
oh, and that's fine, as long as it says Cyberbot.
That's where I was having to disconnect.
Ah, okay, good. So with that understood, what we want to do, glad you asked that, is load save, show files, add file, find your Cyberbot MicroPython, and inside there's cyberbot.py, and hit open. And then verify that cyberbot.py appears in your file list. Now, once that's done, there's a really important next step. And what that is I'll give you a script right here. Let's see, from microbit import, or Cyberbot import star. Alan, what's the pin for the, or Alan or Stephanie, do you guys remember the pin for the, is it 22? Lot of 22.
Mine is 18 and 19.
Okay, but for the speaker, I'm just adding a speaker beep in at the beginning. We won't hear it because we won't have the speaker plugged in yet, but just something that and then we'll get to servos in a minute. Servo control, tone of 22, frequency 3000, duration 1000, and you'll get to try this on Wednesday. All right, so we want to name this Cyberbot template. Okay, I'll paste this in now. Okay, so you want to save this hex file for sure. Chat. Paste. And hopefully I didn't cleverly hide a syntax error in that. Okay, so we want to absolutely, after we've got this pasted in, named Cyberbot template, and then we have the cyberbot.py in our show files. Once all that's done, hit load save and download project hex. And we might actually want to squirrel that one away, like save a copy of it somewhere. So for example, here I have Cyberbot template. And so maybe I'll right click and select duplicate. And then, I think maybe right click and select copy. Let's see here, copy. And then we could, for example, put that on our desktop just to make sure we've got a copy of it. We'll need to go back to this numerous times.
We have some questions. Are
Okay,
these instructions written anywhere to follow along?
yes, they are. So
They're supported with little videos too, correct?
yes, yeah, as
Yeah.
a matter of fact, it's all right. Whoopsie. Sorry, I thought I was on the page. So this is the page where those instructions are, and it talks about downloading, and it shows an example of how to unzip or how to download and then find and unzip the file. And so that's one video clip along with words and checklist instructions that say the same thing. And then there's a step-by-step for adding this to your project right here. And it's all on that add modules to your microbit page that I pasted into the chat earlier. And just so you know where it is in the big picture, if we go to the book cover for the cybersecurity tutorials, writing microbit programs was the homework. And then add modules to your microbit is the very next thing. And that's this page where it goes through downloading and adding it to the project. That's an excellent question. Thank you for asking. Anything else, Stephanie?
Okay. Just some people who are going to do this independently,
Okay.
following those. And then there was a question about a general question from Ellen about from Brian, do students get a basic understanding of Python after going through WHAM and the bot tutorials, or do they need supplemental lessons? And Alan says in his experience, the students get a really good beginning with Python, working with WHAM, but if you're looking for greater Python fundamentals, there certainly is a lot more to know. And I just wanted to point out about that on the tutorial bookcase, so to speak, where the tutorial series is, there's a number of prerequisites. And you're right there. If you could click over to that slide or show for a moment, that writing microbit programs cover some basics, and then the computer microbit talk, the dictionary primer, exception handling, strings and characters. These were also added to support the cybersecurity tutorials, but they are very good fundamentals.
Yeah, lots of
with
computer
Python.
science
Yeah.
curricular check marks are addressed in these as well.
So just wanted to cover those things.
Thank you, Stephanie.
You're welcome.
Excelente. All right, so we've talked about the Cyberbot board already. So this is what we plug the microbit into to make it a robot. And so what we're going to do is connect our microbit to the Cyberbot board. Now, normally you want everybody to unplug stuff when they connect. So it's best to, well, in the interest of time And because I know it's not going to damage anything, we'll skip that. And let's see, where's my box of robot parts? Here it is. So the Cyberbot board comes in a bag that looks like this. And we're also going to need a screwdriver. That's in the box. And inside the aluminum chassis, there are going to be 2 servo motors. That's those guys right here. And last but not least, the battery pack, which is also in with the aluminum chassis. Here we go. So those are the parts we need. Although the tutorial doesn't say we need all of those, I'm trying to get a couple of things done at the same time here. And you'll also need your AA batteries from the homework. And of course, your microbit. So I want all of you to gather these parts out of the box.
While you're doing that, if we flashed that Cyberbot template.
That's a very sage question. Yeah, what happens if we flash Cyberbot template without the microbit being connected to the Cyberbot board?
Errors.
Actually, it shouldn't error. It should just wait infinitely.
I get 504.
Okay, I don't. Oh, wait, here we go. No. Yeah, I'm not getting any errors out of that. It's basically just waiting because it can't find the Cyberbot board. Now, if you want to do a microbit only thing, you still can. You could change this to microbit. And then you could do a microbit command. So we'd have to get rid of the Cyberbot command there, Cyberbot method call. And we could say display dot show whatever. And it'll run now, even though it still has the cyberbot.py file, but since we're not using it, since we're only using microbit, display dot scroll hello flash. And so over here, it's displaying hello. And that's because we didn't use Cyberbot as our main thing. Cyberbot brings in microbit with it. But so if you want to do a microbit only thing, you got to change it to microbit and then use only microbit statements. So I'll go back to what we started with here. There. Okay, so now I'd like everybody to disconnect your microbit from the USB cable. And by the way, this is in a tutorial. I'll show you in a minute, but I'll just show you on screen first. So then with your Cyberbot board, you'll want to plug in the microbit all the way into the socket. So there's the socket, putting the microbit in it. Once I get it lined up and push, you'll hear it click. And then the large circular holes at the base, you'll only be able to see the tops of them. Also, we want to connect the battery pack. The battery pack has a barrel plug and the Cyberbot board. It's difficult to see, sorry about that. There's the barrel jack. Before putting batteries in or reconnecting it to the USB cable, we'll want to connect these servos to the Cyberbot board as well. So here are the servos, and let's see how good of a close-up I can get. Okay, do you see the P18 and P19, everyone? So when you're plugging it in, you want to plug the servos into P18 and P19 with the little plugs so that the white wire is on top, closer to P19 and closer to P18. And then the black wire will be down at the bottom. This is all in the tutorials. I'm just kind of fast forwarding you through it so that we can get our servos centered before the end of the workshop session. And so I will show you either right at the end of the session or at the beginning of the next session where all that is and what it looks like. But here it is for now. So can everybody see that okay? Is that rendering all right on you guys' end?
Yes.
Excellent. So we want to plug in both those servos. So now we've got our servos plugged into P18 and P19 with the white wires closer to the P18 and the P19 labels. Got our battery pack plugged in but not connected. Make sure for starters that this 3-position switch, the 0, 1, 2 switch down here, is set to position 0. So here's the 3-position switch, and we want to have this set to position 0 all the way to the left. At this point, we're ready to connect the batteries and reconnect the USB cable.
Boss, can you show that microbit slide into that CyberOrg again, please?
Yes. Now, some of you may have a Rev B Cyberbot board, in which case you're using Acorn nuts. But I believe we sent out all Rev C Cyberbot boards, which just has this slot right here. I'm looking for an angle that, so there's the slot.
What if I have an old one and I don't have that slot? What would I do? Just shove it in there?
No, with the old one, just a second, I'm looking for an old one. I'm hoping one is nearby. Let's see here. Stephanie, can you paste in the instructions for the?
Just doing that.
Thank you.
So that is the tutorial for Rev A or B, and I'll get to the right page.
Okay, so we're on our way to that. Oh, and you know, Cyberbot tutorial series.
Yep.
And then build your Cyberbot.
That's the Rev C. The
Yeah,
Rev A or B. Yeah.
There's these instructions. So the first thing it has you do is check your revision and then alternately go to a different set of instructions.
Oh, I may not have updated that link when I moved the instructions over. Huh.
Oh, are those the Rev C instructions still? Okay.
Well, I'm hoping the link was made with the node and not with the URL. Let's see. Did it open for you?
Did you paste them in? Let's see.
You're on the Rev C board, correct?
Copy link.
Yes.
Okay, paste.
Oh, I thought you were opening it up.
Oh, okay.
Sorry. Yeah, there we go. And so the second, the connect the microbit, the second bullet point in that list.
Yeah, so connecting the microbit for this one is right here. And so you're going to have a screw, a nylon washer, and an acorn nut. And so you face the part side up, put the screw through the left and right holes, and then attach that screw firmly, finger tight, but pretty tight with your fingers. And then you put the nut on the nylon nut on the LED matrix side. Do it for both sides, and then go underneath and bring the microbit upward, and then cinch down the acorn nuts on top. So that's how you do it for Rev B. And you've got the link in case you are doing that with the Rev B as we speak. All right, so the
Do you
next
have
thing, did I tell everybody to put batteries in and reconnect the cable already?
Yes, do we have to do it in any certain order?
The page goes through that, but or gives you an order, but no, you can put the batteries in first or the cable in first. Either way is fine. Okay, and then we can also set the 3-position switch to position 3, and it'll be displaying the previous script that I loaded. That may not display for you. It depends on what you've got in there. And then I'm going to update this so that with the servo centering stuff. And again, these are instructions. It seems like I'm just like telling them to you, but don't worry, they are also on Learn web pages. So let's see, bot of 18.servo speed of 0. Then we'll do the same thing for 19. Okay, copy, paste, change it to 19. And then I'm going to connect.
That happened to me when I had too many tabs open.
Yeah,
I
for me, I
connected more
think
than
it's I used the wrong USB cable because I'm clearly seeing the other end of the cable I just used not plugged into the computer.
Mine's not liking the bot 22.
Interesting.
Is it bot.pin22?
Bot of 22. No, it should just be bot of 22.tone. Go ahead and comment it out for now, and then we'll get, we don't need that. So there's a hashtag. And then, so here's the script. I'll go ahead and test it first just to make sure it runs for me. Flash. And then once it,
sorry, I was gonna say, it looks like it's taking, it says it's taking 3 arguments, but 4 were given. That must be why bot 22 wasn't working.
Okay, well, let's go ahead and comment. I'll paste in a version that has it commented out. And I just want you to note that as soon as I loaded the script in, the servo started turning slowly. So that's the sign that you're going to be looking for.
Yep.
It's working.
Yeah.
Oh,
It
good
was
deal.
really fine. It was just the tone, and I'm not sure.
Yeah, we can take a look at that afterwards too, to see why the tone was working. I mean, we don't have the speaker in, so the tone isn't
No, it
intended to work, but it's also not intended to give you a syntax error. All right, so does everybody have at this point slowly rotating servos? Thank you for the yes over chat. Can I get some thumbs up? All right, that looks great. Okay, So now the next step is,
Okay, so I don't. So that tells me you didn't see my thumbs down.
oh,
Just remember, I just kind of gave up for a little bit, but then now I'm sort of back on board.
okay.
But you're telling me I can't remember the website that you were doing the editing, so I need to copy something to that Python online.
Okay, yeah, here, I'll paste that into the chat.
Just remind me where I am.
Yeah, it's
'Cause I had the
Python
beta version and then you said not to use that one and
paste. Okay, so there's the website you want to use.
and then
Yeah.
it's just script that you pasted in there, right?
Yeah, except that we need to make sure that you've got this cyberbot.py file.
I do.
Okay, perfect. So if you've got that, then this is center servos, be a good name for it. And pardon me for just a minute. I'm going to turn on the top light to see if I can get a better view for you here. All right. I know that we're at 5 o'clock. If you could bear with me just for another couple minutes, we'll have this done. It's a crucial step. All right. So can you see that hole? There we go. See that hole right there? If you put the screwdriver in that hole, you'll turn one way and it goes faster, turn the other way, it might slow down, go faster the other way. And what you want to do is basically go back and forth with the screwdriver until the servo stops. Like, oh, that one didn't quite stop. There. Takes a really light touch. And do that for both servos. We just want to make sure that, so again, I'm putting the screwdriver in that adjustment hole. It's right by the cable. There it is. Put the Phillips end of the screwdriver in there. And then when you turn it one way, well, it stopped easily. If I turn it a little bit one way, it goes faster. So I want to turn it till it starts going slower. Eventually it'll stop. I might overshoot, in which case I turn it slowly back. And what you want to do is just search for that screwdriver setting that has the 4-pointed star. It's called a horn, and you want that horn to stay still. And once you've got both of those horns staying still, that's a one-time adjustment for the servo. And that is the key thing that we want to get done before the end of the session.
Okay, so I copied the script that was in the chat.
Uh-huh.
I put it into the microbit thing.
Yeah.
I downloaded it and it says port error.
So when you hit flash, you got a message that said port error?
When do I hit flash?
Okay. Are you connected? You want to hit,
Yeah.
if it says connect, click it, and then
It
it'll
says
give,
connect where? In the Python microbit editor thingy?
yeah, in the Python .microbit.org editor, there's the second large button from the left is either connect or disconnect. So if it says connect, it means you're not connected and you want to hit that. Make sure you're
Find the editor again, like I totally lost it. I mean, I downloaded my thing, is how I downloaded and just dragged it and ran it. So obviously I got to do something different.
Oh, well, yeah, you can do that too. You can totally just load save, download Project Hex.
I forgot to do the load save part. Is that the problem?
It's hard to say. I can't see your screen, but that's
For what it's worth, I can't even find the microbit screen that I did it on too, so I'm going a little cuckoo.
Okay, well, we can get you set up after the session if you could stay with us a little bit.
Yeah,
Well, okay.
we're good. I'm just,
Yeah, I mean, alternatively, I can Zoom with you at another time just to make sure you've got all that set up. So get with me on email. You are Jules. Okay. So once you've got your servos staying still, then we'll be ready to put together the robot. And so your homework is going to be to assemble the robot. So there's a build the chassis, and I'm going to send this to you as links. And so basically you'll follow the links, and the first one is going to be build the chassis. And the first thing it's going to have you do is take out all the little parts for the robot. And then it takes you step by step through, okay, here's your parts. Here's a few of the parts that you're going to need. And then here is another picture with them put together. And then once you've got that put together, you'll move on to the next step, which is undo the Phillips screw on these that are holding the servo horns onto the servo final gear. So there's the little final gear output shaft. And it mentions to save the screws. That's really important. And you'll basically go through like this through all these little pieces of putting your Cyberbot robot together. And we'll have you do that so that you'll have a completely built up Cyberbot to start the session on Wednesday. And that concludes the main part of this first session of the workshop. And I'd like anybody who has had trouble with their computer or who is stuck on something, if you can, hang with me and we'll try to get you unstuck. Alternatively, I can take down your email or you can just email me and we can set up a Zoom session to get you unstuck. So that and make sure your servos are adjusted to stay still when they get that stay still signal. And then we'll pick up the rest. We'll pick up with fully constructed Cyberbot robots on Wednesday. Okay, so hang with me, those of you who want to get this finished if you're stuck. And otherwise, thanks for coming. We'll see you Wednesday. And Stephanie, could you end the recording?
Recording stopped.